Hi everybody, welcome to Notes 3.4. Today we're going to be talking about graphing absolute value inequalities in two variables. So let's talk about shading first. If it is less than or equal to, we are going to shade below the absolute value graph. Now, below is different depending on if your absolute value graph opens up or if your absolute value graph opens down. So let's look at if it opens up first. So we look at each side of the absolute value graph. So for this first one, below would be right here. If we look at the other side of the graph, below would be right here. And then of course below the vertex is below the vertex. However, if your absolute value graph has a negative a value, therefore it opens down, let's look at what that would look like. So if we look at this side of the absolute value graph, we shade below. If we look at the right side of the absolute value graph, below would be this direction. So that's why if it opens down, we shade inside versus if it opens up, we shade outside. Now, if it's greater than or equal to, that indicates that we shade above. So again, that's going to be different if your graph opens up versus if your graph opens down. So I'm going to take each side of the absolute value graph. So the left side, if it opens up, above is this direction. On the right side of the absolute value graph, above is this direction. So if it opens up, above is going to be inside the absolute value. But what if your absolute value graph has a negative a value and it opens down? Same situation. We look at the left side of the absolute value, and greater than above would be this direction. And greater than for the right side of the absolute value would be that direction. And of course, above the vertex would be there. So if your graph opens down, then greater than is going to be outside. And if it opens up, greater than is going to be inside. So let's talk about solid or dashed lines. If it is strictly less than or strictly greater than, you are going to graph your absolute value with dashed sides. That's because that indicates that the solutions are only in the shaded areas and not on the lines. If it is less than or equal to or greater than or equal to, we're going to graph our absolute values with a solid line. And that's because the solutions could be on the lines and in the shaded area. So this part of it is very much like when we graphed linear inequalities. Let's look at graphing our first absolute value inequality. They want to know what is the graph of 1 minus y is less than the absolute value of x plus 2. So the first thing I need to do before I can graph this is I need to solve for y. So I'm going to subtract 1 from each side. Now remember, you cannot jump in the absolute value, you cannot dive under and get into the absolute value, you cannot go inside the absolute value. So that's going to be absolute value of x plus 2 and then minus 1. Now, y is negative, so we have to divide everything by a negative 1. So I'm going to divide by negative 1. Remember, there's that imaginary 1 there, and then negative 1. Now remember, anytime you multiply or divide by a negative, it flips that inequality. So that gives me y is now greater than the negative of the absolute value of x plus 2 plus 1. Now we're ready to graph. So we start with our parent function table. Now remember, the b and the h are inside the function, so therefore they affect the x's. We also know it's opposite day inside the function. So the b is 1, so we're like, yeah, whatever, we'll ignore him. But it does say x plus 2. So remember, since it's opposite day, we're really going to subtract 2. So negative 2 minus 2 is negative 4. Negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 1 minus 2 is negative 1. 2 minus 2 is 0. Now, anything that's outside the absolute value bars affects the y value. So remember, we have a negative a value, so a negative 1, and then we're adding 1. So remember, PEMDAS says we have to multiply by the negative 1 and then add 1. So negative 1 times 2 is negative 2. Negative 2 plus 1 is negative 1. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times 0 is 0. 0 plus 1 is 1. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times 2 is negative 2, plus 1 is negative 1. Now we're ready to graph. So you'll see that when we graph, we are going to use a dashed line because it's strictly greater than. And since it's also greater than, we shade above the absolute value. And that is how we determine the graph of 1 minus y is less than the absolute value of x plus 2. Let's look at another example. We have y is less than negative absolute value of x minus 1 plus 2. The first thing we want to do is we want to identify a, h, and k. So a is the value in front of the absolute value bars. So a is negative 1. Inside we have x minus h. So h is 1. Outside we have plus 2, so that means k is 2. Now the vertex is identified as h and k. So in this case, the vertex is 1, 2. We are going to plot our vertex. Now we also know that since the a value itself is negative 1, that means our absolute value graph opens down. Now the slope is plus or minus just the numeric, the number a times b. So if we don't think about the sign on a, that's 1, and then b is 1. So that's going to be plus or minus 1 times 1, which is 1. So therefore my slope on each side is 1 and negative 1. Now, so I'm going to go to the vertex. I'm going to go down 1, over 1 in both directions, then repeat one more time to get 5 points on my graph, down 1, over 1. Now, I am going to connect this with a dashed absolute value graph because it's strictly less than. It's not less than or equal to. If it was less than or equal to, of course we'd use a solid graph. However, since it's less than, we're going to use just the dash. Now also because it's less than, we're going to shade below. We're going to shade below. So therefore, there is the graph of y is less than the negative of the absolute value of x minus 1 plus 2. Now, this says in a complete sentence, describe what the points in the shaded area and on the V represent. Well, the points in the shaded area are what would make my inequality true. However, the points on the line are the V, because the V is dashed. That means that those points will not make our inequality true because it is strictly less than. All right? Let's look at this example. They want us to write an inequality based on a graph. They want to know what inequality does this graph represent. Well, just like we looked at in our 3.3 notes, when we ask you to write an absolute value from a graph, be it an equation or an inequality, we're always going to let you assume that b equals 1. Okay, so we are going to let you assume that b equals 1. And that's just because we don't want you to have to determine, is it an A, is it a B? We just want to keep things as simple as possible. So we are going to, like I said, let you assume that b is 1. Now, the first thing we want to do is we want to identify that vertex. Okay, so the vertex is the h and the k. So I look at this graph and I say, well, my vertex is at 3, -2. So that's going to be my h and k value. The next thing I want to know is, does it open up or down? Well, it opens up. So what does that mean about a? That means that a is positive. The next thing we want to determine is, what is the slope of each side? Well, if I look at the vertex, I have to go up 1 over 1. Or if I go to the y-intercept, I go down 1 over 1. So my slope is 1 and -1. Now let's look at, is it a dashed or solid line? Well, it's dashed. So that means it's going to be strictly greater than or strictly less than. The next thing we determine is the shading. Does it shade above or does it shade below? This is shaded above. So that narrows it down and tells me that it's greater than. Now we compile all of this information. I know that it's going to be y is greater than. We're going to use the positive one for the slope because a is positive. And then we're going to substitute in our h and our k. So we get that y is greater than 1 times the absolute value of x minus 3 minus 2. But since 1 is understood, you don't have to write the 1 unless you just want to. Now, if you don't write the 1, I'm not going to count it wrong. If you write the 1, I'm not going to count it wrong. That leading coefficient 1, the a value, that's strictly up to you if you would like to write it. The following slides are additional examples should you want additional practice. So let's look at those. I've given you the inequality. I've demonstrated how I would graph it and my rationale between dashed and shading. Same with the second example. And lastly, with the third, I've given you another example of writing an inequality. So if you wanted extra practice, I would recommend maybe covering up with a Post-it note the stuff on how to solve it and just looking at that. Can you do what the problem is asking? And that's it. We're done. Your homework is now worksheet 3.4. So you will complete that, turn it into your teacher, and then have a great day. All right. Thanks for watching this video, and y'all make it a great day. Please remember to socially distance, wash those hands, use hand sanitizer, and take care of yourself. Have a good one, guys.